This one, it says defensive blood cells. Defensive blood cells. Probably everybody uses this one. And then I'm going to do a review, or partial review of this one. Yes, you got it. Okay, so that's what you look at. What do you mean? Defensive blood cells. Okay, I'm just going to pick up the hands up. Defensive blood cells. That's why I couldn't find it. There's the toxins. Somebody put defensive blood cells in front of it. Let's help you out. Who needs the toxin handout? I'm going to do some old ones. Who needs the toxin handout? This is what I went over and drew. Then we'll get defensive blood cells. Who needs the toxin handout? Who else needs the toxin handout? I'm sure you have that before we leave. Don't leave without 10 minutes. This is the toxin. Okay, that's the one I drew on the board. That is the one I drew on the board. Now, defensive blood cells. Let's not put that one on top of this. Let's put that one. Is another one. This is the next chapter. This is innate immunity. Innate immunity. Innate immunity, a couple of key points about it. Next chapter. You guys need it? Pass this one down. These out so I can start talking.
I have two extras.
You have what?
I have two extras.
Yes, you have two extras. Pass two down. Okay, still working to give out the handout on defensive blood cells. Anybody else? Okay, we're going to put our toes into the next section, and then I'm going to try to give you a review of infection. Innate immunity. It is almost impossible to tear apart the systems of the immune system. But one way they teach is innate immunity here and adaptive immunity over there. Do they overlap and intertwine? Yes. Okay? You cannot completely separate them, like you really can't completely separate knowledge sometimes. But to get a start, innate immunity means that system does not have to be programmed or coded at all. It simply attacks anything that has patterns that are non-self. Anything with patterns that are non-self. The difference between that and adaptive immunity is when adaptive immunity, those cells have to be computer programmed, have to be given orders to assassinate, or those cells will sit there and the pathogen can go right past them and they won't do a thing. The adaptive immunity has to be coded, has to be activated. The innate immunity is already constantly owned and attacks anything that's what? Non-self. That includes allergens, by the way. Allergens. Now, you're also born with the innate system. You're born with it. With the adaptive system, which I'm going to tell you a little bit about that later, they have to have processing or activation or maturation of the cells. Now, we're going to go over this handout right here. The defensive cells. Some of this you already know from nursing, some of you don't. These are your basic cells. And let me put it up here real quick. I still want to give you my PowerPoint. Let me give you PowerPoint next time. I'll put it in, don't worry. I just flipped you, you're supposed to change. I'm thinking about it. There you go. Okay. These are your cells. The basophil, okay, call it a neutrophil, eosinophil, monocyte that matures and differentiates into a macrophage, and of course your lymphocytes, which are your B and T cells. I'm going to say it again. Basophil, neutrophil, eosinophil, monocyte becomes or differentiates or matures into a macrophage, and a lymphocyte would be your B and T cells. We are not talking about the lymphocytes except for the special natural killer. This is under defensive cells right here. Under defensive cells right here. Right here. Okay? That's where it is. You're hunting for it. You can group them in two ways. A lot of people group them by whether they look grainy or not grainy. that means you have to look at a certain magnification, and if you change the magnification, it's worthless. But a lot of labs do that. A granulocyte means smooth. A means what? Not grainy. The other one is grainy. So it's real easy. Basophils, eosinophils, neutrophils look grainy under that magnification. I have pictures for you later. Your lymphocytes and your monocytes appear smooth. I prefer to group them this way, by how they act. But that's just a microbiologist. That's just a microbiologist. Those that are phagocytic, what does that mean? Those are ones that will actually eat the invader. Actually eat the invader. And then others that are just for inflammation, that was inflammation, but really don't ever do any phagocytosis. And last is your adaptive immunity. Those are your lymphocytes and your B and T cells. Okay, phagocytic, those are your big three. Neutrophil, monocyte that becomes your macrophage, and to a lesser degree, the eosinophil. Inflammation only. Basophil. He never eats anything. He releases chemicals to help call other organisms to come, cause chemotaxis, or to help cause the inflammation. That's what he does. Platelets simply help you do what? Clot. They simply help you clot. Now I'm going to give you a couple more things about neutrophil, eosinophil, monocyte. Neutrophils tend to go after bacteria. So I've learned this from the get-go. Neutrophils tend to go after bacteria. Eosinophils, of course, can go after bacteria, but they also tend to increase in number a lot when there's a helminth infection. What does that mean? Worm. Worm infection. Okay? If you're dropping down to your lymphocytes, such as your T lymphocytes and that, that's usually viral. Viral infection. Now here's the thought I want you to think of with that. If the person's neutrophil numbers are way up, they probably have a what infection? If the person's eosinophil levels are way up, they probably have a what infection? Parasitic worm infection. If the person's T cells, TC cells type of lymphocyte are way up, they probably have a what infection? Biviral. You see the associations there? I wanted to get that much into the next chapter, and then I'm going to give you a review for the last 5 minutes.